So a second video about equivalent fractions. And this time we're going to try to start with more pieces in the whole and end up with fewer pieces in the whole. So last time we did a half and we did 2/3. So not very many pieces in the whole, and then we broke the pieces up to get more pieces in the whole. So now we're going to go in the other direction. So now we're going to start with a drawing that has lots of pieces and try to figure out a way to redraw them or group them so that we have fewer pieces in the whole. This is also called reducing fractions. So let's find some equivalents to 4/8. So let's draw it. Hopefully you're sort of figuring out by now, I love to draw my fractions. So here's my 4/8. So notice I took this rectangle, I broke it into 8 equal parts, and then I shaded 4 of them. So there's my 4/8. Now, if we sort of look at this, maybe squint a little, it looks a lot like half of this rectangle is shaded. Okay, well, we know that a half means one piece that's shaded, 2 pieces in the whole. But the way it's drawn right now, I have 4 that are shaded and I have 8 in the whole. So let's figure out a way to sort of redraw that. And I'm going to do that using blue lines. So if I just look at these blue lines, now I have just one piece that's shaded and I have 2 pieces in the whole. So now I have a drawing that is 1/2. But notice, if I look at the top rectangle and the bottom rectangle, they're the same size and they have the same amount shaded. So this is showing that 4/8 is equal to or equivalent to 1/2. So let's try to find another one. So I'm going to draw out my 4/8. Same thing, 8 equal parts, 4 of them are shaded. And last time we sort of did groups of 4. So we took these 4 to make one new piece and these 4 to make one new piece. So now let's try groups of 2. So now I have 2 pieces of my old little pieces make one of my new big pieces. So now, again, the 2 rectangles are the same size, have the same amount shaded, but looking at the blue lines, let's figure out what this is called. So now I have 1, 2 that are shaded, and I have 1, 2, 3, 4 in the whole. So that's 2/4. So by grouping them a little bit differently, I've shown that 4/8 is the same as or equivalent to 2/4. So let's try again. Here's my 4/8. Instead of groups of 4 little pieces together or groups of 2 little pieces together, let's try groups of 3 little pieces together. So we're going to take 1, 2, 3 of those little pieces and see if we can group them like this. So there's 1, 2, 3 pieces, 1, 2, 3 pieces, 1, 2 pieces. Okay, hopefully you just caught our first problem. There are 2 with this particular problem. 1, there are 3 pieces, but they're not equal size. This piece is not the same size as this piece. And when we're talking about fractions, equal size pieces is very important. The second thing to notice is that this middle piece is only partially shaded. So it doesn't really get to be included in the shaded part, but it's shaded, so we don't want to ignore that part of it is shaded. Now, this particular problem has both of those errors, right? Not equal size pieces and only partially shaded piece. You only need one of those for this grouping not to work. So let's try another one. Before you go on, I want you to try this one on your own. Okay, so grab out some graph paper, get some paper, grab a writing utensil, and I want you to draw out 24/36, and then I want you to use that drawing to come up with some equivalent fractions. So try to find 3 different fractions that are equivalent to 24/36 that have less than 36 pieces in the whole. So go ahead, press pause, try it out. Okay, hopefully you have some drawings, some beautiful drawings on your paper. So let's talk about some possible solutions. So here's my 24/36. So if you notice on the top, I took 36 equal pieces, and then I shaded 24 of those 36. So you can see why graph paper might be really nice here. Easier to count out your 36 and to make them about the same size. So one way to find an equivalent fraction is to group them into groups of 2. So by taking 2 of the original 36 and I merge them into one piece. And so now, looking at the bottom rectangle, I can count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces that are shaded. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 pieces in the whole. So using this grouping of 2, I can show that 24/36 is equivalent to 12/18. Same idea with groups of 3. Again, my original 24/36, and now I took 3/36 to make my new piece, and I'm going to count again. I have 1, 2, 3, 4, 5, 6, 7, 8 pieces that are shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces in the whole. So my new fraction is 8/12. So 24/36 is equivalent to 8/12. Trying again, now I have groups of 4 for my 36. Again, top rectangle is 24/36. I group 4 of those together to make my new piece, and then I count. 1, 2, 3, 4, 5, 6. Shaded 1, 2, 3, 4, 5, 6, 7, 8, 9 in the whole. I apologize, it's a little repetitive, but right, this is what we're going for. This is the practice that we need to make sure you understand. Now I tried new pieces of 5. So now I took 5 little pieces, and that's my new piece. And now I'm going to count. 1, 2, 3, 4, 5. Oh, what's going on here? That's probably going to be a problem. Okay, so right away, as I just go to count them, I notice that this shape is partially shaded. If one of your new shapes is partially shaded, that doesn't work. You cannot group that way. This also has another problem. If we look way over on the side here, I have this one little teeny piece that's hanging out. Okay, so my pieces are not the same size. They are also has a partially shaded piece, so this will not work. So let's try 6. So again, I took 6 of my 36, I put them together, and then we count 1, 2, 3, 4 that are shaded. 1, 2, 3, 4, 5, 6 in the whole. So I have a new fraction of 4/6. Now we try 12. So I have 12 of the little pieces became my one new big piece. And if I count, I have 1, 2 that are shaded. 1, 2, 3 in the whole. So there's my 2/3. So 24/36 is equivalent to 2/3. Now you'll notice we skipped 7, 8, 9, 10, 11. They don't work. If you tried them, hopefully you figured out why they didn't work. If you're not sure, try a couple out. Make sure you understand why those groupings will not work. Okay, let's try another one. So 5/20. So again, pause this video, try it on your own, and then we'll go through the possible groupings. Pause it. Okay, hope you have some great drawings. Pulled out your graph paper, drew 5/20. So this is what happens if you try to group this. So if you try to do groups of 2, you'll end up with one group that's not fully shaded. If you try to do groups of 3, you'll end up with not equal sized groups. If you try to do groups of 4, one group is not fully shaded. If you do groups of 5, this is the one that works. You have one shaded group, you'll have 4 groups in the whole, so that will give you 1/4. So this will show that 5/20 is equivalent to 1/4. All right, 12/18. Again, hit pause, try it on your own, draw 12/18, and see if you can come up with some equivalent fractions. Okay, let's check over some little answers. If you tried groups of 2, you should have come up with 6 shaded, 9 in the whole for 6/9. If you did groups of 3, if you started with your original 12/18, you should get 4 shaded, 6 in the whole, so that's your 4/6. Now, not to confuse you, but if you had started with your 6/9, if you did groups of 2 and got 6/9, and then from there did groups of 3, then you would end up with 2 shaded, 3 in the whole. Either way is fine. Groups of 4 or 5, not equal size groups. Groups of 6, you should have come up with 2 shaded, 3 in the whole for 2/3. Now notice, I got 2/3 here and I got 2/3 here. Breaking something up into groups of 6 is the same as breaking something into groups of 2 and then breaking those into groups of 3. So if I have a whole bunch of things, I put them in piles that have 2, and then I take 3 of those little piles, right? Now I have piles of 6. So those are equivalent. Okay, some closing thoughts. Use what you already know about fractions to find equivalent fractions. In other words, draw. It's not about finding new fractions quickly or fast. It's about finding new fractions in a way that make sense to you. Use your drawings, go with what you know. Remember, equivalent means that they're worth the same amount, they have the same value. And again, I'm going to stick this definition up here every chance I get. Fractions are number of pieces selected divided by the number of pieces in a whole. Now, some of you might have listened to this whole video and said, I already knew how to reduce fractions. You just divide. Reducing's all about dividing. Why didn't you talk about that? And I'm going to tell you, I did. Grouping and division are exactly the same thing, okay? Grouping is one interpretation of division. So we did do that. But if you're one of those people who already know how to reduce with division, that's fine. I don't want you to forget that, but I want you to be able to also do it with drawings, and I want you to be able to connect the drawings to the division that you already know. So let's go back to our 12/18ths and talk about maybe why this didn't work for those of you who like the division. Right? So groups of 2 worked, but groups of 4 didn't work. So what's the difference? Well, if we go to groups of 2, we can see that 2 goes evenly into 12, right? So those 12 shaded parts, when I grouped them, then became 6 shaded parts. And if I take the 18 total pieces, I put them into groups of 2, that gave me 9 new pieces in my whole. So groups of 2 worked because 2 went evenly into 12 and 2 went evenly into 18. Now looking at 4, why 4 didn't work, if I come to my numerator and I try to take 4 into 12, no problem. So all those 12 shaded pieces, if I break them into groups of 4, that gives me 3 groups that are shaded. The problem is that when I try to take 4 into 18, then I'm not going to end up with equal size groups. I'm going to end up with 4 groups that are the same size, and then I'm going to end up with that last group only having 2 of the little pieces in it. So 4 doesn't work because 4 doesn't go evenly in the 18. In other words, taking 18, breaking it down into groups of 4 will not be able to do that evenly. Okay, so if we continue to look at that, 3 works because 12 can be broken into groups of 3 and 18 can be broken into groups of 3. 5 doesn't work. 12 cannot be broken evenly into groups of 5 and 18 cannot be broken evenly into groups of 5. In groups of 6, that does work because 12 can be evenly broken into groups of 6 and 18 can be evenly broken into groups of 6. So this idea of grouping and this idea of division are exactly the same thing. So if one way makes more sense to you, if one of those vocabulary words works for you, use that one.